Good morning. Can you hear me okay?
Yes, ma'am.
Okay, good. I just want to make sure that you can hear me. Henrietta won't be here today because she has that other class, so she sent me a message. I can't believe they let her enroll, you know? Well, it is what it is. And it does say 11:15, so it's not like it doesn't. 11:15, no, 11:45 is what it says, right?
Yes, ma'am.
Yes, you should have known that that's just not going to work. It's only 15 minutes for the other class.
It's another woman. I don't know if she got added to the roster yet. Her name is Jocelyn. She said she's doing this class. I seen her the Zoom.
Okay. You've seen her here?
No, ma'am. She said she's supposed to edit your class last.
Okay. Oh, you told her that it was a Zoom?
Yes, ma'am. I told her it was Zoom and in person. I told her she would like you because she didn't like the chemistry teacher she had, and I told her to get Miss Vibes.
Who did she have? Do you know? Remember,
yeah, I don't know.
You don't know?
What you said?
You don't
know,
remember?
ma'am.
Okay. Let me check and see if she's added to my participants, and I can tell you.
Yes, ma'am.
Let's see. Oh, not a lot. A lot that aren't here. I would take her off. She's a teacher. She needs to go away. No, I mean, there's no need for her to be on this one. Is there? Let's see. See, he's no longer. I know Madalicia's supposed to be here. There's Henrietta. There's Dr. Galierus. There are a lot of people.
Just for this class?
Yeah, but really only one. There's Taylor. You said her name was what?
Jocelyn
Fragata?
Yes, ma'am.
Yeah, she's here. I see her right there. Yeah, can you see my screen?
Yes, ma'am.
Okay, because I'm sharing it. See, her name's right here where I'm pointing. Yeah, okay. That's weird. I need to find out how to get rid of some people. Choose. See, it doesn't say to send a message, doesn't say anything about unenroll. Used to be you could do that, but not anymore. I don't know how to do it anymore. I actually put a person in my own classroom myself, but I couldn't get them in this time. Okay. All right, well, let's get started. Let me go out of here and go back in here. What you doing, my kitty cat? If you hear a meow, it's my cat. You will hear him meow because he's very meowy. He meows a lot. All right, let me see. We were looking at scientific notation the last time, right?
Yes, ma'am.
All right, so let's go down to that area. Okay. So right here. And we're gonna probably, and this is open for you, by the way, so you can start doing that if you want. The assignments, the 2 assignments that are on Moodle are actually on Moodle because a lot of people always have some sort of issue making their account. Did you have any problems making your Connect account?
No, man, you remember I already had an account.
Yeah, I know you had one, but I mean, a lot of people have problems, but you didn't have any, right, of any kind. getting on or whatever?
No, ma'am.
Okay, so you went directly.
I watched the videos.
Okay, good, perfect. All right, so here we go. Okay, sorry, that was some other thing I must have had open. Okay, so this is what we're going to do next. I'm gonna make it as big as I can so you can read it. All right, there we go. I think that's about as big as we can get it. All right, so in order to write the following number in scientific notation, you notice that it is already in a format that would go to scientific notation, which it is. But what you need to do is you need to write the same number because they're asking for scientific notation. Man, he knocked over my speakers. And there should be 10 to the 0. Oh, sorry, 10 to the 0, not 100. I'm just about to flip this up. Like that. Because 10 to the 0 is 1. Sorry, I'm picking up my speakers.
You're fine.
Knocked over this child of mine. This furry child. Anyway, so yeah. So when you do in times 10 to the 0, anything multiplied by 10 to the 0 is 1. So whatever you multiply that, 10 to the 0 is 1. So it's going to be the same as this, right?
Yes, ma'am.
So that's what you want. You want to make sure that you know. There we go.
So how did we get to the 0?
10 to the 0, huh?
I said, so how did we get like 10 to the 0?
Because the 0, since we need to have a scientific notation, remember the thing about scientific notations is that this number right here, which I'm highlighting, right, has to be between 1 and 9. And it is. That one, the first one, see, this one doesn't meet scientific notation. The next one, B, does not. But A does. Because the first number before the decimal is between 1 and 9. So since it is already in the right format, the only thing to do is to multiply it times something. If you multiply it times 10 to the 1, that would be like saying times 10 and it becomes 21, which is not the right number. So you have to multiply it by something that doesn't change it in this case. And 10 to the 0 is equal to 1, always. So that's what you do. You multiply it times 10 to the 0. Okay, in this case, this one, you have 2, right?
Yes, ma'am.
And if you put a 0.0, that would be wrong because there's nothing after the 2. You see that?
Yes, ma'am.
And then you want to multiply it times what? Well, let's see, times 10 to the something. This is larger or smaller than 1?
It's larger.
No, this is smaller.
Oh, the small. I thought you were talking about the 2.
No,
it's,
the whole number. It's smaller, right? Okay, so
yes.
now we need to count how many times we need to move the decimal. That'd be 1, 2, and 3. You see that?
Yeah, 10 to the 3.
Negative 3, because
Negative.
it's less than 1. Yeah, negative 3. And that's where we are. Oh, come on. We're not doing this right. There we go. And I'm just going to change it to red. Makes it easier to see the answers. All right, so this one, we need to decide where the decimal is going to go, right? Remember, so it has to be between 3 and 4, right? Because it has to meet those conditions that the first number before the decimal or the understood decimal has to be between 1 and 9. So 3.45, because all of these don't count, right? Because this doesn't have a decimal place. So it would be 3.45 times 10 to the what? Well, let's see. We need to see how many times we have to move it. 1, 2, 3, 4, and 5. So times 10 to the 5th. To the positive 5 this time, right?
Yes, ma'am.
Because it needs to be the same number that you counted, plus this is larger than 1. Okay, there we go. All right, the next one, I should have put them a little bit farther out even. I tried to put them far enough that it wouldn't interfere with the other one, but this one was longer. Okay, this one, okay, so this one's the same 3.45, right?
Yes, ma'am.
But this time we gotta count, and it's less than 1, so we gotta count it again. 1, 2, 3, 4, right?
10 to the negative 4.
Yes, very good. And now I'm just gonna make it red so that it'll, okay. So you do this one.
Okay, so it's 5, I don't know how to pronounce the number, 5 million.
Okay, yeah. Oh,
Okay,
I thought you were saying it's 5. Yeah.
The decimal is gonna be 5, between the 5 and all the other zeros.
Right, so it's 5, right? Because
Yes.
all these sig figs do not count because there's no decimal, right?
Yes, ma'am.
So you just need a 5. Oh, that's too far. 5. Okay, I'll just do 1 tail. That's good enough. 5 times what?
5 times 10 to the 1 power.
No, you have to count it. Remember, 1, 2, 3, 4,
I
5,
forgot we had to count
6,
back.
7, 8, 9. Well, because it's larger than 1, it's going to be backwards.
Yes, ma'am.
Okay, so it's not 5 times 10 to the 9th in this case, right? And that's the correct answer, okay?
Yes,
So
ma'am.
you can do the next one?
Yes, ma'am.
Okay.
Okay, so it's going to be, the decimal is going to be between 7 and 5.
Okay, so you notice that all those other numbers count. So it's 7.50.
Yes, ma'am.
Times 10 to the what?
Let me see. Let me zoom in. 1, 2, 3, 4, 5, 6. 10 to the next 6.
Negative 6, correct. Oops, I went too far. Okay. Yeah, 10 to negative 6 because it's less than 1. Remember, if it's more than 1, it's positive. If it's less than 1, it's negative. And this happens definitely to be less than 1. All right, so this one?
Put the decimal between the 2 and a 7.
Okay, so 2.7. And how many times did we move it?
1 time.
Okay.
It's going to be positive.
Yes, correct. Tends to the 1. All right, so we are going to put it up so it doesn't look like 101, which would be totally wrong. Okay, and there you go. And then this one.
It's E.
I don't know why it's not. And we're gonna have to leave it really close because it doesn't want me to put it where I want to put it. You notice it flicks this one out.
Yes, ma'am.
No. Enter. There we go. It flicks it out. Whatever. I'll just leave it like that. Okay, now I can do it. So it's
okay. So you're gonna put the decimal between the 2 and the 9.
okay. So 2.9 and then all the other numbers, right? 2.973 times 10 to the what?
Okay, so you're gonna do 1, 2, 3. You're gonna do 10 to the 3rd.
Negative 3.
Yes, ma'am.
Because that's smaller, remember?
Oh, yeah, it sure is.
Yeah, if it's smaller than 1, it's gotta go negative. Okay, there you go. That's how you do it. Okay, now we're doing the opposite. So we're going to convert it back. So how do we do that? Okay. Remember that the negative is telling me one thing, which is what we know, which is that it's less than 1. So that means we got a 0 in there, right?
Yes, ma'am.
And we got to put 5 zeros in here, or 4 zeros. 1, 2, 3, 4, and then the 3. And then that makes it, so if you look at it, if we go backwards, 1, 2, 3, 4, 5, you see?
Yes, ma'am.
Okay, so that's that one. And let's just change it, the color too. Okay, what about this one? Let's see. I still have to go in here. I still have to go in here and do this. And I went too far. There. Darn it. Okay, so that one, hey, you notice it's negative again, so we need a 0. And then we need to figure out how many spots. Okay, it's giving you -3. So you always do 1 less 0 than the number. So
yes,
1, 2 zeros, and then the 7, 2. You see?
Yes, ma'am.
When they're negative, not the positive. The positive is totally different. It just depends on the number itself. Okay, here we go again. I'm gonna do this anyway. All right, so this one is 5.0, but times 10 to the -7. So 0 point, and we said 1 less than the number, right? So,
So it's
1,
gonna be
2, 3, 4, 5, 6. And then the 5 and the 0, because if the 5 and the 0 are here, they are needed here, okay?
yes.
If they're there, you gotta keep them. Okay, let's see this one. Okay, all right, so this one's positive, all right? So in this case, what we have to do is we have to put the 9, 1, right? And start right here. So it'd be 1. Now we got 2, 3, 4, 5, 6. You see that?
So we do the same amount of.
Yeah, you put it where it normally is, right? And
yes,
then you move it 6 times. 1, 2, 3, 4, 5, 6. And that's the answer.
Oh, okay. I get it.
Okay, same with this one. Okay, remember 10 to the 0 means what? 1, right?
Yes, ma'am.
So then the answer is 8.2. See, nothing changed because you don't move it any spaces, right?
Yes, ma'am.
So you just write it back again without it, is what that means. Okay, so if you don't move it any spaces, it's a 1, right?
Yes, ma'am.
That's where that comes from. Okay, this one on the other hand has 2. So if we write the number 298, right, and we start moving it, that's the way it goes. So we're going to be moving it twice. 1, 2. That's it. That's the answer. 298. Because the decimal would be at that end. Okay, let me see this one. Okay, this one is 2980 -2. So it starts with a 0, right?
Yes, ma'am.
And then we said we only put one less 0 than the number. So it's just 1 0 in this case. And then the number. And all of these numbers are significant. So you need to put 2980. And that's your answer. So see, if you were to convert it back, you will see how well this works. Okay, so we want it between 1 and 9, right?
Yes, ma'am.
1, 2, see? That was where it goes. So it's -2, you see? And all of that would count because everything here, since it has a decimal, everything here needs to be 2.980. Okay, this one says to move it 1 spot, and that's where we started, right?
Yes, ma'am.
See, it does that. I don't like that. Okay, so it started there. So if we move it 1 spot, would be there. So that would be where your period is. Right? I mean, sorry, that's not where it starts. So one movement, that would be there. So it's 37.9. I'll just make that red. Okay, so that's how that works. All right. Now, here's some rules. And I'm gonna write them in red over here. Okay, when multiplying, multiply the m's. Remember the m's, they're the number, right?
Yes, ma'am.
And add the n's. Okay, not the, no, there, at the ends. Okay, so what does that mean? Okay, that means that you're multiplying 2 times 4.0. And here you have to remember your rules of scientific notation. So 2 times 4.0 is 8, but there's only one sig fig on 2, right? So you say 8, right? And then you say times 10 to the what? Well, we said we are adding the n, so that would be 3 plus negative, right? 6.
Equals.
Yeah, but I'm going to bring this up so that we know that we're doing it above, not below. Okay. All right. So that would be equal to, I should always do this before I go there. Remind me to put an equal before I go there. Okay. So that would equal to 8 again, right? But this time is times 10 to the what? Well, what is 3 minus 6? It's
3 minus
3, right?
Mm-hmm.
Okay, so there you go. That's how you do it. It's pretty simple.
So, okay, so where did we get the 8? So we added 7. What did we get the 8 from?
We multiply 2 times 4.
Okay, that's right. That's right.
It's
and
8.
Then
but then we keep only the one that has the lowest amount of sig figs, which is that one, right? Which means we only keep 1. And then we add these two exponents, this one and this one, right?
Yes, ma'am.
And there, that's a negative, so then it becomes a negative, right? Because it's larger. The negative is larger. So when you're really adding, you're subtracting, right? But you keep the sign of the larger one. Does that make sense?
Yes, ma'am.
Okay, so here is 8 times 4. That is 32, right?
Yes, ma'am.
Okay, and each one of these has 2 sig figs, right? Both of them have 2 sig figs. That means 32 is good. We don't have to do anything to it, right? And then there would be times 10 to the what? Well, that would be 3 plus 9, right? In this case. I'm just going to bring it up a little bit so we can get that one. Go up. There we go. All right. See, I said, remind me to hit the equal before I do that. I keep forgetting. All right. So that would be equal to 32, right?
Yes, ma'am.
10 to the 3 plus 9 is 12, right? All right. So this is one problem that I'm seeing. That number that we have first. I went the wrong way. That number that we have first, right? The first number, 32, is not between 1 and 9, right?
Right.
So what do we need to do? We need to convert it. How do we convert it? Remember what I told you? If you want to move this back 1, right? That means you're decreasing it. So then you increase this one by 1. And that's gonna, yeah, so that's gonna give you 3.2
plus 13
times 10 to the 13. Yeah, correct. There you go. So that's how you do these. They're not hard. Remember the M is the part with the number. The N is the exponent, right?
Yes, ma'am.
Because it was M to the N. Let me see if I can still do this thing that I used to do. Okay, yep. Okay, so that is a format. M times 10 to the N, right? So we multiply the M's and we add the N's. You see that? Okay, so let's stop this. All right. I need my mouse back. Okay, so then here. Okay, so it's 37 times 2.
0 times 10 to the negative 8 equals.
Mm-hmm. 74, right? Did you get 74?
How do we do this one again?
Remember,
So we do 70.
you multiply the numbers, 32 times 2. And they both have 2 sig figs, so 74 is good, right?
Yes, ma'am.
Okay, see, they both have 2 sig figs. And then we add, well, is there any exponent on 37? No.
No, ma'am.
So then we just keep that one, right? Times 10 to the negative 8.
8.
That's our answer, except it's not in correct scientific notation again. So what did I tell you to do?
Put a decimal between 7 and 4.
Correct. I keep forgetting to put the equal before I go up. Then I have to go back and do it. Okay, so 7.4, right? And if you do that, you are decreasing it, correct?
Yes, ma'am. So it's 10 to the negative 7.
Correct. Wow, look at you. Good girl. You got it. Yeah, exactly right. Exactly right. That is how it's supposed to be. Excellent. See, I didn't even have to tell you. You already know. All right, so you do the next one then. You tell me what to do.
Okay, so we're going to do 10. We're going to do 7.52. Do we do times?
Times, yes.
3.2. Let me get my calculator. what did I say?
7.52.
0.52
Times 3.2.
You said 3.2? Which is 26.32.
26, I get 24. Ooh, are you sure?
Hold on, let me see.
Okay, because that's almost like saying 8 times 3 is 24.
7.52.
You should get 24 point something.
You said times or plus?
Times.
Times 3.2.
I get
24.064.
That's what I got. Okay. All right. Times 10 to the what?
Times 10 to the negative 9.
Plus 4, right?
Yes, ma'am.
Okay, which is going to give you what?
Negative 9 plus 4.
I remember that.
Add first 10, 11, 12, 13. 13, and then minus.
Not 13, because it's negative 9 plus 4. So
Okay.
negative 9 it's like saying 4 minus 9.
So 4 minus 9. So 8, 7, 6, 5.
Negative 5, right?
Yes, ma'am.
10 to the negative 5. I forgot the name. Okay.
Okay, so I have a question. So when a bigger number. So when a bigger number is negative, that's when we subtract.
No. No. You always subtract if you have a different number.
Yes, ma'am.
Okay. So if you have a positive and a negative, you subtract. Doesn't matter which one's bigger, which one's smaller.
Okay.
But you always also have to remember that you're adding, and adding in when you're adding in algebra, right? It's always a plus, but since you have a negative sign, it becomes a negative. Does that make sense?
Yes, ma'am.
So it becomes a subtraction rather than an addition, because if you're doing negative 9 plus 4, it's going to be negative 5, right?
Negative 9 plus 4 are going to be negative. Yes, ma'am.
Okay, yeah. All right, but if it had been positive 9 minus 4, it would have been positive 5. But see, you're still subtracting. So it doesn't matter whether it's lower or higher. It's just what it tells you is who's winning. So basically, which one's larger, that's the sign that you keep. Right? So yes, negative 9 plus 4, like I said, is equal negative 5, because negative 9 is larger than 4. But if it had been 9 plus negative 4, it would have been positive 5 because 9 is larger than 4. And, you know, the sign that prevails is the one that has the largest number.
Right.
Okay. So here, the last thing we need to do, well, we need to do 2 things. We need to first limit our sig figs, and we have 3 in that one, and we have 2 in this one, right? So that means we can only keep 2, right?
Mm-hmm.
Okay, so we can only keep the 24 because the 06 doesn't make it go up. And then it's times 10 to the -5, right?
Mm-hmm.
And that's gonna be equal to, remember what we do? We decrease, so we increase, right? So 2.4 times 10 to the what?
-4.
Correct. There you go. And that is how you do that one. And I do it very, very detailed at first, but I won't be doing this much, you know, later, because you should know what I'm doing by then, because you know what you're doing now. So I believe in you that you can definitely do these on your own. Okay, stop that. It was stuck. That was weird. I'm just gonna put the ultimate answer in red, so that way you'll know which one's the true. Well, obviously it's the last one, but I just like it. I like red because it just makes it, you know, more visual. That's the true answer. Okay, now we had division. Okay, for division, okay, so I'm gonna add here at the bottom, when dividing, divide the m's, right? And this is gonna be interesting. Add the n on top to the reciprocal. You know what a reciprocal is?
No, ma'am.
Okay, I'm gonna explain it. Of the n on bottom. In bottom, yes, on the bottom. Okay, so n on. I'm just gonna, there. Okay, so what does that mean? All right. We're dividing 2 over 4, so that is 0.5, right? We know that, okay? So what am I saying here? I'm saying I'm adding the 2 numbers, but first I gotta put the 3, right? And then I have to say plus, oops, sorry, plus what? Okay, -6, but the reciprocal is the opposite of -6, which is +6. You see that? So yes, in order to cross the line, you know, from bottom to top, it has to change signs. Okay.
Mm-hmm.
So, oops, before I forget. Otherwise, I have to go back and redo it again, and it's just annoying as heck. I do not like doing it 20 times. All right, so that's the answer. No, it's incorrect, right? Because the first number has to be between 1 and 9. And is it?
No, ma'am.
No. And also, well, right now we only have 1 sig fig, and that's all we need is 1. Okay, so 5, we just increased it, right?
Mm-hmm.
So what do we do to the exponent, which was a 9, right? We decrease it, oops, decrease it.
Make it to 8.
Yeah, no, +8, because it's 9, +9.
Mm-hmm.
-1. I did it again, oops. I forgot to put the equal before. It's annoying otherwise, like I said. Okay, so 5 times 10 to the, oops.
-8.
+8.
I mean, yeah, +8.
Yeah, okay, and there's your answer. That's the whole thing. See, it's not as complicated as it may seem. You just gotta remember that one thing. It has to be the reciprocal, which means the opposite, which opposite in this case means in sign, right? All right, let's do this one. 8.0 divided by 4.0. Well, that's 2.0, right?
Yes, ma'am.
And we keep the O because we have 2 sig figs. And see this one, oh, let me highlight. Oh, I can't highlight these because these are divisions. So I cannot highlight it. But as you can see, the 2 has only 1, whereas the 4 had 2. So we can really only keep 1, which is what we did here. This one has 2, this one has 2, so we must keep 2. All right, so that's going to be times 10 to the what? Okay, so 3, right? And the reciprocal of 9 is -9. See?
Yes, ma'am.
Okay. So in this case, we need to go and say the answer is, and this answer is easy because we just subtract now. Times 10 to that. So who's winning? Who's larger? The
Then
negative or the positive? All right, so then it's -6, you see?
Yes, ma'am.
Okay, and that's that. We're done. Are you getting how this one works too?
Yes, ma'am.
Okay, good, because you're about to do one yourself. Okay, so right here, remember, 37 doesn't have anything, therefore, you don't have to subtract actually. Okay, so divide 37 divided by 2.
Okay, let me go to my calculator. 37. I typed in 37 divided by 2 is 18.5.
And then what do we do? Times 10 to the what?
-8.
-8 is on the bottom. What does it have to do to come up?
-0.
It becomes +8, right?
Okay.
Remember that?
No, ma'am.
Yeah, it has to come. If it see how it did? See how this one was 9 and became -9. This one was 6 and became +6. You see that?
Oh, okay. Okay, yes, ma'am.
So anything that's coming up is going to have to change sign. Now, is this good enough for us or do we need to change something?
It should be good though.
No, something's not right. Oops, no. Undo, sorry. I ended up getting everybody smaller. No, I don't want
No,
to.
you gotta put another number.
Yeah, I know. And I tried to do that, but when I went up, see, I forgot to put my equal. All right. So first of all, how many sig figs can we have?
1.
2, because we have 37 and 2.0, right?
Oh,
So
yeah.
2 sig figs of 18 is going to just be right here, right? Right there. Oops, I'm going to highlight both. Yeah. So we're not going to put 18 because it has a 5. So it's 19, right?
Yes, ma'am.
Times 10 to the 8. Okay. And then that's going to be equal to, remember, the rule says that we cannot have that our number before the decimal has to be between 1 and 9. Well, 19 is not 1 and 9. So we need to say 1.9, which means we decreased it. So what do we do to the exponent?
Make it a 7.
Make it, we increase it. We decrease one, we increase the other. Remember that? Okay, so still, that the answer is going to be 1.9 times 10, oops, where's my, times 10 to the 9. See that time? Do you see why?
Yes, ma'am, because you increased it.
Yes. So remember, whatever you do to the m, right? This is talking about the m, you do the opposite to the n. Okay, so let me put all these up so that way it'll make more sense now when you look at it up. Because this is being recorded, as you know. That's for whoever else wants to look at this lecture. Okay, and there you go. And that's how you do it. All right, so now let's do this one. Okay, you divide.
Okay. 10.52, I mean 7.52 divided by, let me go to it, 3.2. 2.35.
Okay. All right. Now, what is the thing that we need to do? Times 10 to the what?
-9.
Plus?
Plus, let me see. 10.
No, not 10. Remember, the bottom number has to come up. And in order to do so, you have to change its sign. See that? So basically, you're adding -9 plus -4. Because the bottom sign has to change. Remember, the reciprocal means the opposite. Okay. So when we add these two, which we're really adding, but it's negative, right? It's -13, yes?
Yes, ma'am.
Okay. So then that's our answer, except for one thing. We have two sig figs on the bottom, so we really can only keep to there, right? So that should be 2.4. And there you go. So that's the real answer right there. We're gonna go up on these. Just so that you know that it's negative, because it looks like -13. I know, but it's the only thing I can do is just write them and then bring them, bring them back up afterwards. So that you can see what that's supposed to be doing, which is all exponents. Oh, and I forgot to color this one red, didn't I? Okay, and then this one's red too. All right, so there you go. So that's how that's done. You see? All right, we have one that has multiplication. Look at that. And then division. So you multiply the top first and then divide the bottom. Okay, so we have to do two things. We have to do the multiplication on top first, right? So we're gonna do that. So that's 8 times 5. That's 40, right? Times 10 to the what? Well, it's -4 plus 6. So, see, I told you, oh, I forgot one thing. I have to stretch this one. This is the most annoying thing because it is a, so then I have to get this one back. So I have enough room. I know, it's weird. Okay, so, oops, I overdid it. And I can't read it. There. There we go. Now I can read it. All right. All right. So it's -4 times 6. That gives me 2, right? Because it's 10 to the second, because we're adding those two. Remember, I told you I was going to make it so that I'm no longer writing all the stuff. Okay. So that right there is going to be divided by, right? The bottom. So we haven't touched the bottom yet. We're just going to say 8 times 10 to the -7, right? So far, this is what we have. Oh, let me put an equal first. Okay. So far, this is what we have, and that's all we have. We don't know anything else. Okay, now we need to do the same thing that we learned. So first we applied the rule for multiplication, which we did, which is 40 times -4 plus 6, which gives me 2, right? And then the bottom one we haven't touched. So now we divide the 2. 40 divided by 8 is 5, right? Okay, then times 10 to the what? Okay, so we had a -7, right? And we're bringing up a +7 because it's negative. Therefore, when we go up, it's positive.
Right.
So that's going to give us 5 times 10 to the 0, right? Okay. So let me, no, did I say, what in the world? No, not 10 to the 0. I'm crazy. You should have said something. No, 10 to the 9. Yeah, you should have said something. I'm like, wait, I'm going crazy. No, this is to the positive. Yes, to the +9. Because I don't know where I got the 7 from. I was looking at the same 7 twice, I guess. I was not looking at the right thing. And then I'm going, no, this doesn't look right. But yeah, it does now. All right, so that's our answer right there. your ultimate answer. And it's good because it has the right amount of sig figs already. You noticed? Because we could only keep one. See, all of them have only one. All right, let's do the bottom one ourselves. Okay, but first, let me stretch it. It's so annoying. Bring it back. I have to find the little place for it. Right. Oh, there it is, right there. Bring it back. There. Okay. So remember, the first step is to multiply the top. So do that.
5 times 2. Let me
5.8. 5.8.
Huh? Let me see.
It's 5.8 times 2.
Oh. 11.6.
Yes. Okay, 11.6. And this is times 10 to the what?
Negative.
Yes, negative, it is right. But negative what? So you're doing negative 7 plus 4, right?
So 8, 9, 11.
No, go the other way. Because look, they're opposite signs. So that means they subtract.
They showed, I forgot. 3.
Yes, that is correct. And that then we divide that by 4 times 10 to the, and I'm just going to put it down, negative 6, right?
Mm-hmm.
Okay, so I'm going to, and that's going to be equal to something. Okay, so let me do this because all of this looks like a mess right now. And I can't stand it when the exponents aren't exponents because that gets confusing. It looks like 10 minus 6, which is not. It's 10 to the negative 6. Okay, so now we need to divide 11.6 into 4, right?
Mm-hmm.
So do 11.6 divided by 4. And that gives me 2.9. Now what you got?
2.9.
Okay. Now the next part is where it gets kind of hairy. So we need to say 10 to the negative 3 plus, right?
Mm-hmm.
And notice that there's a negative 6. So when it crosses up, it goes positive. So that's our answer right there. So it's 2.9 times 10 to the what?
Positive 6.
3.
I mean,
right? Positive
yeah.
3 because we're subtracting. All right. Okay. So we've got that. Now, one more thing. Sig figs. See how many sig figs are in 2 of those? 1, right? This one has 2. So what is 2.9 in 1 sig fig? 3.
2.1.
Yeah. So when you round up, right? Becomes 10 to the third. 2.9, if you round up to 1 sig fig, right? It has to be 10 to the third. I mean, 3. Sorry, 3. I don't know what I'm saying. I'm looking at 10 to the third and I'm saying the wrong thing. Sorry. I said 2.9 rounded to 1 sig fig is 3 because it is large enough to make that 2 go to 3, right? And that is the ultimate answer right there. All of that, right? Just for that little thing. Okay, so let's do this one. Let me go ahead and stretch it. Bring it back. All that good stuff that I do. There it is. Okay, now, all right, so it's 8.4 times 9. What does that give you?
8.4 times 9. 8.4 times 9. 75.6.
Okay, and then now our exponents times 10 to the what? Well, it's negative 7 plus negative 6. So we're adding them, right? Because they're both the same kind, but it retains their sign. So that 7 plus 6 is 13, right?
Yes, ma'am.
Okay, and then we divide it by 8 times 10 to the to positive 6 because we're not there yet. So we're just doing this one step. So now we need to pull this one up. Oh, let me put it on first. Otherwise I have to go back and do a third time. And I don't need to do too many times. It's already hard enough as this is. Okay, so not insert. There you go. Okay, so now we need to divide the two numbers. So 75.6 divided by 8.
Okay, let me go do it. 75.6 divided by 8 is 9.45.
Okay. Now remember the exponents goes negative 13 plus the reciprocal, right? Of what's on the bottom, which in this case is 6, but the reciprocal of 6 is negative 6.
Right.
So you end up actually adding all of them, right? So it's going to be 9.45 times. Okay. Guess I didn't stretch it enough. There we go. Times 10 to the, let me just make it a lot shorter without putting spaces. That way maybe we have a chance of getting everything in there all at once. If I put spaces, it makes it longer, you know? Okay, times 10 to the, okay, so negative 13 plus 6, negative 6 is negative 19, right? Because they're all negative, they add. So that's our exponent there, right? But we still have one more thing to do that we haven't finished. We have to cut the sig figs. Sig fig cutting to 1, right? So 9.45 is 0.45 large enough to make 9 go to 10? The answer is no, right? So then it's times 10 to the negative 19 there. Oh, I tried. I'm trying to get them all in there, but I don't think I'll be able to. No. Even with all the, oh, here's the space I didn't see. The equals have to have spaces. No. Okay. So it's not going to let me. So I'm just going to go ahead and push it to the other end. So it'll be on the bottom. That way we have our answer right here. Okay. All in one place, you know, because it gets weird if not. You have to look for the next line. Okay, so you see how that was all a big entire thing to do. Now it went. Since I'm making them go up, maybe it'll all fit. We'll see. So I'm making them smaller. Nope, it still didn't fit. Well, I don't know, it might. I think it will. Look at that. It does fit, yay. Once I make this smaller and get rid of that space, it will, yay. Okay, so, no. Darn it. I'm telling you, this thing is annoying, the way it's made. There. Okay, so I'm just wanting to change that to red so that you know that's the actual answer. All right, so all of that to get to there. Same thing here. We're doing the same several times because that's how you learn, right? By doing. If you don't do enough, you don't learn. That's why I take the time to, oh, come on. There it is. To do plenty of them. Okay. So that first thing is 5 times 7. That is 35, right? Times 10 to the what? Oh, I keep forgetting the times. Nope, times 10 to the 1. Okay, so got negative 4 and negative 6. So that's,
you got
yes, go ahead.
Okay, negative 4 times 6.
No, not times. Remember, we add the ends.
4 divided by 6 is...
No. Okay, we multiply the m's, right?
It's 10.
We did 10 to the 10, negative 10 though, right?
Yes, ma'am.
Okay, yes, all right. Now we're still dividing by 4 times 10 to the 5, right?
5.
Yeah, and that's going to be equal to, all right, let's find out. Right, so 35 divided by 4 is what?
35 divided by 4. 8.5, 8.75.
8.75. So we put that on there. And we cut the sig figs at the very end, you know, because otherwise it gets too much. All right, so times 10 to the, we have negative 10 on top. The bottom is a 5, right? So that becomes plus, and then we have a negative 5 because remember it's the reciprocal of it, right?
Mm-hmm.
All right, so in this case it's 8.75 times 10 to the, so it's negative 10 plus negative 5 is negative 15. Because they're both negative, so they add. All right, so that's our real answer, except for one thing. We only need one sig fig. And the one sig fig would be there, right? Mm-hmm. And that 0.75 is large enough to make that go to 9, yes? So the answer is 9 times 10 to the, oops, I keep forgetting, I don't want to put that. Negative 15, right? All right, so let me go back and put all the negatives, all the exponents up, so that way we'll see what we're talking about. See how this one just kind of got cut off. But it'll work. I think it'll work once we get it all in there. So this is all exponent stuff right here. So is this. Mm-hmm. Why did you do that? I went to the right spot. I guess I must have pushed it out before I could actually elevate it. All right. Oh, there's a space. See, I leave spaces because I'm used to having to put the right way. There we go. And there's your answer. The ultimate answer is right here. Okay. All right. Now the bottom one, the next one, number 8, it's the same thing. You just got to do the bottom first. Okay.
So 3 divided by 6.
Mm-hmm. Yeah, let me stand this. Yeah, while you're calculating, I'll do this, all this other business that I have to do with this one. Okay, so it's gonna be, we're just gonna leave the top untouched, right? So 8.7 times, oh, I did it again, times 10 to the negative 6. Okay, divided by, now you can tell me what the bottom is. So 3 times 6 is?
3 divided by 6.
No, not divided, multiply. See how it's multiplying?
18.
18, and then the exponents. Negative 4 plus 4 is 0, right?
Right.
So I'm gonna go ahead and, it looks like times 100, so I'm just gonna go ahead and elevate them now because it won't be confusing. Because times 100 looks weird. See, I knew that you would eventually encounter something that was a 0. That's why you needed to know that that is really nothing. You know, it's just a 0, right? Just like with anything. All right, now let's divide 8.7 over 18. So 8.7 first, right?
Mm-hmm. Divided
by 18. And that gives me a real small number because obviously, what did you get? 0.433333333.
Let me see, 8.7 divided by 18. Yeah, 0.48333. Yeah.
Oh, there's an 8. I didn't see the 8.
Okay, hold on, let me see.
Yeah, I see. No, you're right. You're right. I didn't see the 8.
Oh.
So since we already done all the math, right? 0 doesn't matter if it comes up or down, it's gonna be 0. 0 doesn't have a sign, right? So it's gonna be to -6. But what is wrong with this picture? 2 things, right? We need sig figs. So the sig figs should cut there. So that means this is 0.5, right?
Mm-hmm.
Times 10
because
to the
8 is bigger than 4.
Yes. Okay. All right. Yeah, 8 is bigger. And so it makes that 4 go to 5. And then one more thing. Is that incorrect scientific notation?
Which one?
The number, this one that we're just made.
Yes, ma'am.
No, it's not. Remember that first number has to be between 1 and 9. Is 0 between 1 and 9?
No, ma'am.
So then we need to move it 1.
That's why I'm out here thinking about something else. I'm out here thinking about it.
So if we increase it, right, we decrease the other one. So it means it's -7. You see that?
Mm-hmm.
Okay. So let's make all of these nice and pretty because this is annoying. I can't stand it. I wish this thing could just hold an exponent, like you could push a key or something and make it up that way, but it's not letting me. So there is no key to make it up. Okay. So that is the true answer right there with all the sig figs and all the math done. All right, you notice the next one's a multiplication and a multiplication and then divide it. So we need to do the multiplications first in order to get this correct. Hold on, let me do my thing. This one's gonna take as much as possible. So I'm gonna make it as small here as I can. So I have enough room. Okay, that's about right. All right, so 6.2 times 9 is what?
Okay, 6.2 times 9 is 55.8.
Now the exponents, -6 plus 4. It's gonna be negative, right? Because 6 is larger than 4. And it's by 2. Right. Divided by, okay, now let's multiply 8.6 times 7.
Okay, let me go do it. 8.6 times 7, 60.2.
60.2. And I know I have to do the division with a line, but you know, I don't have capabilities to do that. And then you've got the exponent. So
it's 0.
It's 0. That's right. All right, perfect. All right, so let me go ahead and put these up and down so that way when you do the reciprocal, well, obviously the reciprocal is a 0, so who cares, right? But we still have to do that part. Okay, so let's divide the two numbers. 55.8 into 60.2.
Okay, let me do it. 5.8 into 60.
55.8.
Yeah, 55.8 divided into
60.2. Just like it says, yeah.
My number shows 0.9269103.
Okay, so let's leave it at 9269, so 927, right? Because we don't need but one sig fig at the end, as you can see, because this number right here, right? This one and this one, they both have just one. So, and then times 10 to the what? Well, times 10 to the second, -2, right? Because -2 plus 0 is still -2. Okay, but that number is not correct yet, is it?
No.
So we need to say 9.27, right? Times 10 to the
into
-2. It's still the same. But we lowered one, we increased one, so we need to decrease by 1, right?
Mm-hmm.
So we increased the 0.9 to 9. So that means we need to decrease this one by 1. And -2 plus -1 is -3, right? So, or -1, if you want to call it, is -3. So we are decreasing. And now the last thing to do is the sig figs, which we haven't done. Sig figs say we only can keep 1, and that would be there. Is that 27 large enough to make that 9 go to 10?
Yes, ma'am.
No, it's not.
You said, Lord.
No, it's not. Because see, that 2 is not beyond 0.5, which is half, right? So it's less than half of this, of 1.
Oh, I thought you said 27. Like I thought
no,
you
that
wanted
9.27. I said that 27. Yeah, because see this right here, the 0.27, large enough to make that 9 go to 10. No, it's not. So then it's 10 to the -3. That's it. That's the whole thing. That's how you do these. And you notice we're getting progressively more complicated, right? Because we're learning more. And you may have a problem just like this one that you'll have to do for conversions or for something like that, that you will definitely need to know how to do this. All right. Okay, so that's that one. Now let's do the next one. Actually, you do the next one. See what you get. Do the whole thing by yourself. And you can look at the, the other ones too. Okay, there you are. I was like, where are, oh, no, this one, do you see that? That's crazy. It's like it blocked me over here on this side. Oh, look, there's 2 things. That's so weird. I've never had that happen before. Okay.
7 times 6 is 42.
Okay.
So 7 divided by 2. Oh, 7 times 6 is 42. 10 -4 to the 10 -7 is, so we subtract, it's going to be 6, 5, 6, 3, -3.
Yes. Because I was waiting for you to tell me.
Okay, you're going to do 5 divided by 8.
No, multiply.
5 times 8 is 40. So you're going to do -7 times, 10 to the -7 times, 10 to the -7. So -7 minus -6. Where is it? Where's my calculator? It's -13.
1.
Hold on, let me see.
Because you notice the other one's not negative, it's positive. Right? The 0.6 is a positive number. The 10 to the 6, is a positive number, not a negative. So you're subtracting -7 plus 6 or -6 is going to be, so 6 minus 7 basically is -1, right? Okay, so now what is our next step?
Our next step is I forgot this step. I think it's the 42 divided into 40.
Yes.
1.05.
Okay, and then now what's the math being done on the exponents? Oops, I already put times. Times 10 to the what?
Let me see, times 10 to the -2.
-3 plus 1, that's right, -2. All right, so the last thing to check is this a correct scientific notation? Yes, but is that correct sig figs?
No.
Okay, so what do we cut it to?
We cut it to 10.5.
No, to 1. Remember, because 1 sig fig in each one of these. See, that's 1 sig fig, right?
Oh, that's right. That's right.
Okay, so then we need to cut this one to 1, right? Which gives us 1, right? Just 1, because 0.5, right, is not large enough to make 1 go to 2. So it's 1 times 10 to the, and you already have the answer, -2. And that is the whole thing. Sometimes they're a little bit easier, like this one, because you didn't have as many steps, if you notice. We didn't have to get anything changed, hardly. Like we did in the other ones, because the number was already in the format that it needed to be. The only thing we needed to do was cut the sig figs in this case. All right, and then this right here is the ultimate answer. Okay, so that's all of them. We are done with all of these. Oh, okay. I see how you are. So this is where this one is. There, see, right there. There's a movement. Oh, I am not finding it. I'm gonna leave it alone. Yeah, no, it's not here. Oh, I know, I'm just picky. I don't like the way it looks, but it's all right. It doesn't affect the outcome in any way, shape, or form. So there you go. That's the whole sheet. Worked. Did you work it on your papers to make sure that you had all these answers?
Yeah, well, I worked some of them.
Okay. Okay. All right. So that's that. We are done with this part. Now, what we're going to do is we are going to learn something else. Oh, sorry, not that one. Okay. So right here, we are in the middle of doing this. All right. So we are now moving up. You know, so we're going to the next forum. Next forum, next topic, which we are going to, oops, don't go so far. All right, so we're looking at metric conversions. Okay, so this one. But first we're gonna look at the metric system. And you need to download the conversion chart, the 2 conversion charts, these 2. Have them handy, okay? All right, so let me go to metric system. Oh, and let me erase that. There we go. All right. Come on, metric. Let's go. It says it's opening, but then it doesn't open. There it goes. All right. Here we go. All right. So for this one, don't look at the page numbers. I always mean to erase them and I keep forgetting because that's not our book anymore. All right. So conversions. Okay, the very first thing to do is to find the difference between the exponents of the 2 prefixes and move the decimal that many places. Which way? Okay, so the way that I say is to the left or to the right. See, I hate left and right. I like negative and positive, right? And in this case, if you're going down, right? So if you're mega to centi, for example, you find the difference between 6 and -2. But in this case, remember how we were adding 6 and -2? It's going to be 6 minus -2, which makes it positive. Here, let me write this down for you so you'll see what I'm talking about. When you have a number that is negative, right? And you're subtracting it, these 2 multiply, and that becomes 6 plus 2, which is equal 8. So when you're going from mega to centi, you have 8 spaces to move. Now, if you're going from mega to centi, that means you're going down. And that is a positive direction, right?
Mm-hmm.
But if you're going from centi to mega, that means you're going up, and that is a negative direction. So let's say that you had 2.5, right? And you wanted to go from centi to mega. So centimeters, right, to megameters. Okay, that's an M. Okay, so we're going up, right?
Mm-hmm.
So we just counted that it was 8. So the answer is times 10 to the negative 8 megameters. You see that?
Okay, so what did we get 10 to? 10 from?
6, 2. No, not 10. Remember, we're just doing the exponent. All we're doing is the exponents. We're saying 6 minus negative 2 is equal to 8, right?
Mm-hmm.
So then the number, which is this, times 10 to the negative 8, because all of these are negative. See, these are exponents that right there. See that?
Mm-hmm.
These are exponent negative 6, this exponent negative 2. But since we are subtracting,
Oh, okay.
we're actually adding them. All right, so let's say we had, let's erase that one. And let's say we wanted to go to, from kilo to micro, okay? Right, so we'll do the math first, right?
Mm-hmm.
3 minus negative 6. That's equal to 9 spaces, right? So we would need to move times 10 to the 9th. All right, say we have 4.2 and we wanted to go from from kilometers to micrometers. Okay, so we already have the M part, right? So all we need is the exponent, and we just said it's 9. And that would be micrometers. Because we're going in a downward direction, right? It's a positive. You see? We just need to know the number of spaces we move, but which way, to the right or to the left? Remember that question? I don't like right or left, I like positive or negative. So since we're going down, it has to be a positive. If we were going up, it would be a negative. Because if you think about it, if you take a whole, a piece, and you divide it into 10 little pieces, right? And you want to find out how much of a whole is one of those pieces. Well, it's 1/10, right? So that means it's 10 to the negative 1 piece, you see? Because we're going the opposite. But if we take the whole and we divide it into 10 pieces and we say, now we're dividing it into this many pieces and one piece is a whole, it's not a whole. One piece is part of the whole. So how many pieces do we divide it into? 10. So then it's 1 times 10 to the 1. I mean, 10 times 10 to the 1 instead of negative 1. You see? So basically, what I'm asking is, say we have this. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's 10 pieces, right? That we divided it into. All right, so if we were to convert that little piece to this whole piece, right? That would be only 1/10 of it, right? Because we divided into 10 parts. But if we wanted to convert this whole thing into this many pieces, that would be times 10, right? To the 1, because it's 10 of them. You see what I'm saying? So 1 times 1/10 is 10 to the negative 1. See, this is equal and this is equal. So we have times 10 to the negative 1 if we're going up, right? Because we were going from the little one to convert it to the largest one. So we were going up. That's a negative. But if we're going from the large one, converting them to the little ones, that's a positive. Okay. All right, let's do one. I need my mouse back. Nope, mouse, come here, mouse. Okay. All right, see? And they say move left, move right. I don't like move left, move right. I like positive and negative. Move left is we're going up, right? So we're going to do negative. And move right, we're going to do positive. See, that's how it works. All right, so, all right. Okay, so this is one way to do it, and what another way of doing it. And what you do is you identify the starting and the ending units. You line up the conversion factors so that the units will cancel. Then you multiply all the top numbers and divide each bottom by each bottom number. Check your units and your answer. Okay, so what does that mean? Okay, let's say we're wanting to convert, oops, sorry. Here we go, 1 inch, right, is this much, okay? So we know that. That's called a conversion factor. Now, okay, so in this, yeah, hold on. Yeah, this is, I don't like that part. Okay, so how many milliliters are in 1 quart of milk? Okay, so beginning unit is 1 quart. Oops, sorry. I hate when I do that. I keep forgetting that draw. Okay, so 1 quart, right? We know that's our beginning units. And you notice it says how many milliliters. That's our ending unit, right? Okay, so 1 quart, you put 1.00 quarts. That's how you do. You start with your beginning unit, QT, right, quart. And we know, based on our little thing, that there are, let's see how many liters in a quart, 1.04 quarts in a liter, or 1.04 liters in a quart. I can't remember which one it is. Hold on. Let me find my, remember I told you to download those conversion charts? Mm-hmm. That's why, because you need them. Let me go get them. Mine are not in here. Okay, they were in here. I just didn't see them. Oh, I see them now. They're under my stuff. Okay, there we go. So I have the conversion chart. All right, 1.04. Let's see. There are 1. This is volume, by the way. So you're looking at the volume conversion. And we'll look at it in a minute. There is 1.06 quarts per liter. Okay, so what it said, to find out your conversion, right? And line it up so that these units will cancel. So in order for it to cancel or divide out, that one has to go on the bottom, right? So we said there is 1.06 quarts in 1 liter. So now the last thing to do is change it to milliliters. And if we looked at the thing that we have, and we'll look at it in a minute, there is for every liter, sorry. I meant to do liter, not milliliter. For 1 liter, we have 10 to the 3rd milliliters. So then the answer is 1, right, times 10 to the 3rd divided by 1.06. You see that? Or remember how we did before? You just divide 1 into 1.06. And if you do that, 1 into 1.06 gives you a number. All right, so let me go back over here and let's stop sharing this part. I'm gonna clear all these drawings too. I'm gonna stop sharing this part and I'm gonna show you what I'm talking about. Stop share there, yeah. Okay, so we're gonna share, but it's something else. I'm gonna share my screen, but I'm gonna go to escape. It's not letting me escape. Why are you doing that? I said stop share. Okay, let me go find what I need first. That's what the problem is. And there we go. All right, so now I'm gonna share something else so that you can see where we're gonna go, okay? All right, see, this is the metric to metric conversion chart right here, which I call my ladder. You'll see in a minute, hold on, it's coming up there. All right, so what you do with this one is you count the spaces. That's how I made it. And remember, going up was positive, right? No, it was negative, sorry. And going down is positive. Okay, so I'm gonna write that down. Come on, let's enable your editing. There we go. All right, so I'm gonna write that down on here for you, and you can write it down in yours when you print yours. Okay, so going down is positive, going up is negative. And they want us to go from, and you notice that the prefix is right here, right? And then the other part, depending on what it is, if it's length, it's gonna be meter, right? Right here, see, right where it says unit. See right here, meter, gram, or liter. Well, they wanted us to convert liters to milliliters. And we're going down, right? So we got 1, 2, 3, or you can use 10 minus 3, right? So 10 minus 3 minus negative 3 becomes positive 3. And in this case is a 10 to the third because it is a positive since we're moving down. Okay, that's that one. That's where we got that number from. This is called a conversion because it's, you have to find all of your, okay, so we're going to go now to the next one, which is the metric to English conversion chart. And this is where we found the quarts. Okay, see the quarts in gallons right here. It says very clearly 1 liter equal to 1.06 quarts. You see that? Okay, that number, the 1.06 goes with quarts and the 1 goes with liter. So now that you see where we got all our stuff from, let me go back to the problem. All right, and we were at the problem, so let me go back to that part. I know sometimes it gets kind of crazy.
I don't know about understanding, like.
Okay, but you're about to. Okay, so I was just showing you where we were getting all these numbers. Okay, so 1.06, 1.0 quarts. Remember, we had an equality that said that that says 1.06 quarts. It's supposed to be a period, but it doesn't want to give me one. It's equal to 1 liter, right? And how do we know where to put the quart? Well, we want it to cancel, so it has to go on the bottom, right? See? And it goes with 106, so you put the 1.06 here. And the liter, right, goes on top. You see that? Okay, so let me clear all this so that you can see it coming up. Okay. So back to my mouse. All right, here we go. Well, they have 0.057, which I put 0.06, but that's all right. They just use one more significant figure. They're just using one more significant figure than I do. Okay, see how I did that?
Where do we get the 101?
I showed you where I got it. That's why I went over there. I showed you where we got it from. It's a conversion chart. let me see. No, I think I closed them out. Yeah, no, there it is. See, right there.
Mm-hmm.
So that's known as a conversion chart. You have to either know the values or you can look them up, which is what I have. You know, this is why I gave you a chart. You don't have to remember everything. I mean, it's a lot to remember right here, right?
Mm-hmm.
So we're just, and these are all the units. There are metric units, length, mass. Volume is a derived unit, but we're still using it because it is part of a metric. And then time. All right, so that's what you need to download, this chart. All right, and the other one, okay. So then the next part, I showed you where I got that from, remember? Okay, I said 1 liter is equal to 1,000 or 10 to the third milliliters, see? Remember, 1,000 is equal to 10 to the third. All right, so we need to cancel liters. And now what we do is multiply, divide, and that gives us 946 milliliters, or 0.946 times 10 to the third, you know, which is the same, either one. Okay, now look at that. You have 1.5 pounds of gold. Okay. Oh, Jocelyn's here. Okay.
Yeah, I just told her one.
Okay, so here we go. Find its volume. Okay, so how do we find volume? Volume, we have density. So density is mass over volume. So if we use density as a conversion factor, we need to convert pounds to grams first, right? In order to use that. So to do that, we need to go back. Oh, I shouldn't have erased it. Oh man, I can't believe I did that. Hold on, let me close this out. And then go get those two that we'll need. I don't know why I closed it. I didn't mean to close it, but all right, so metric conversion chart you'll need, right? So make sure you have it handy. A metric to English conversion chart you will also need. So they should both be around. But right now we need this one because we need pounds to kilograms. And there it is. You see it right there?
Mm-hmm.
Let me make it bigger so you can see it better. Okay, right there. Pound to kilogram. See, there are 2.2 pounds, and they're probably going to have this number because they're more precise. But I like to use the 2.2, not the 2.205, which we don't really need on that. Okay, so 2.2 pounds per kilogram. And then we're going to have to convert kilograms, right? That we just converted from pounds to grams. And remember, kilo, right here, is 10 to the third grams. So see, 1 kilogram is 10 to the third grams. So whatever the number is written here, that's how much of the unit being either meter, gram, or liter, right? Right here. You see that? These are. So if you're going from kilo to gram, which is the unit itself, it would be kilogram. That'd be 1, 2, 3 going down. So it's 10 to the third. All right, let me go back. Now keep those two in mind because we just found them, right?
Yes,
and
ma'am.
go back over here. All right, now let's go back and do this. All right, so you remember 1.5 pounds is where you're starting, right? And we're going to centimeter cube. So we found out that there are 2.2 pounds per kilogram, see? And we want to put the pounds below because we want to cancel the pound part, right? All right, now we need to convert kilograms to grams. Remember we said that 1 kilogram was equal to 10 to the third or 1,000 grams, see? Now we have finished converting that part, but the ultimate thing that we want is centimeter cube. And there's your conversion right there. See how it says grams per centimeter cube? So there are 19.3 grams in 1 cubic centimeter of gold. All right, so down here, what do we do the next step? Okay, which one goes with gram? The 19.3, right? So then the 19.3 has to go on the bottom and the 1 centimeter cube goes on the top. To get the whole answer, what you do is you multiply all of the top and divide it by the product of all of the bottom. So to do that, best way to do this, and I like doing this, is I'm gonna show you with keystrokes on your calculator and you follow me, okay? So basically you're gonna do parentheses, 1.5 times. Notice 1 is not gonna matter, so we're not gonna put the 1, but we are gonna put the 1,000. Close it. Then you're gonna do a keystroke of divided by, okay? And then open it again, okay? And then the bottom is gonna be 2.2, right?
Mm-hmm.
Times 19.3, because the ones are not necessary to multiply by, you know that. And then you're gonna hit equal. Now, if you followed that exactly like I did it on the calculator, you should get your answer. So 15 times 1,000, right? Close the parentheses, divided by, open the new parentheses, 2.2 times 19.3, close that parenthesis, hit equal. Just like that. You get this number. Which is 353.27, right? Is that what you got?
I don't really understand.
I mean, 35. Wait, hold on. What did I do? I must have not multiplied times 1,000. Oh yeah, I know what I did. I multiplied 15 rather than clear. Okay. All right, so, okay. If you have a calculator, put that in it, just like it is, just like it is. So open a parentheses, right? Put 1.5 times 1,000. Close the parentheses. Hit divide by, open a new parentheses, 2.2 times 19.3. And then close that parenthesis and hit equal. And that should give you 35.32736693, some big long number. But since we started with 2 significant figures, right? Right here, only 2, right? Because these are all conversions, so conversions don't have significant figures. We started with 2 sig figs, we need to end with 2 sig figs. So our answer is gonna be 35 centimeter cube, because you notice that pounds cancel, kilograms cancel, grams cancel, and the one thing that we wanted, which we knew from the beginning, we were converting to that, is what we ended up with. Okay, so did you do what I asked you to do? Using the parentheses and all of that?
I'm trying, but I don't really understand.
Okay, you have a calculator, right?
Mm-hmm.
And hopefully it is the one I suggested, that you use a TI 30X2S.
Let me see.
A Texas Instrument one, which is about $12. Sometimes you can find them even less.
I don't know. Let me see.
All right, so if you put 1.5 times 1,000 in its own parentheses, right? So that means, see, what you're telling the calculator is you want it to do that operation first, the one that's in parentheses. Then you want to divide it by the product of the next one. And that's what it's telling, what it's going to do. But if you don't put the parentheses, it's not going to work. Okay. So you got to do 1.5 times 1,000 in parentheses. then divide it by, open a new parenthesis, 2.2 times 19.3, and then close that parenthesis and then hit equal. And that should give you 35.327, blah, blah, blah. See, all we're doing is taking the numbers on the top that are, see, these two numbers right here on the top. And then we have these two numbers right here on the bottom. You see that? Oops, I circled when I needed to not circle. I meant to underline and then circle. Yeah, there you go. So that's all we're doing. But we're telling the calculator to do it all at once. And in order to do that, you have to do what is known as order of operations, right? So you always do the multiplication, whatever's in parentheses first, and then you divide. So basically you're doing 15,000 divided by whatever 2.2 times 19.3 is, I don't know. What is that? That is 42.46. So basically that's what you're doing. You're dividing 15,000 divided by 42.46. And I got exactly the same number. Yep. I mean, I said 15,000. I meant 1,500. 1,500. Yeah. And it gave you 35 point. Okay. So once you do that, you have to make sure that your sig figs are only 2, because this one, let me clear this one and make it a different color so that you'll see. Let me take blue. All right, so this is sig figs 2. These are 2 sig figs 2. So that's what you want. And that's it. That's the end of that one. That's how you would do the whole conversion. Let me clear all these drawings and go to the next one. You'll get it as the more we do. Okay, so there's another one. All right, it says how many liters of water would fill a container that measures this much? Okay, first of all, we need to go from inches, cubic inches to liters. And there's one thing that is in your conversion chart, well, isn't in your conversion chart, that says that 1 centimeter cube is equal to 1 milliliter. So let me put
I think I'm just gonna have to get to understand it. It's my chart, because I don't really understand it.
Yeah, you need your charts. That's what I told you. You need to download them. 1 centimeter cube is equal to 1 milliliter. Okay. So since we know that, we know we need to change inches cube to centimeters, right? So let's say it's 75.0. So we would have to go from 75.0 cubic inches, and you notice it's cubic. So there are no conversion factors to actual cube. So what you're going to have to do, and see, according to this count, this thing is 1 inch is equal to 2.54 centimeters. But unfortunately, these aren't cubed, right? So we need to actually cube this. And now you have inches cubed. Then you need to change, remember centimeters equal to milliliter, centimeter cube is equal to 1 milliliter. So you say 1 milliliter, right, is equal to 1 times 10 to the negative 3 liters. And that's also in your chart, because if you go up, which you would need to go up, that would be what you would get. So the very first thing here that is confusing is to elevate that to the cube. So your calculator should have that. Or you can multiply 2.54 3 times. But basically you just say 2.54 elevated to the third. And that gives me 16.387, blah, blah, blah. So then that times 75 and times second EE -3. Okay, that is equal to 1.2290298. So that's what I get. Let me go ahead and make this go on there. Even if it's on top of mine, I'll clear it afterwards, but that way you'll see it. Okay, so see, same thing I did, right? And then you got the 2.54. See how they cubed it? The cube is because this is in cubes. So you cannot say it's something that is cubic is equal to something that is not in cube, right? So, and since there are no conversion factors, all you have to do is cube it or elevate it to the third power, which is the same thing. All right, and the next part, we said that, see, they did it backwards, but remember reciprocal, 10 to the third, 10 to -3, yeah. So depending on whether you want it on the bottom or on the top, it changes sign. I wanted it on the top because I like to multiply everything all at once instead of having to divide. And I still got the same answer, right? I said 1.229. And the reason they cut it down to 1.23 is because you started with 3 sig figs and you ended with 3 sig figs. You see that? Okay, let me clear all of these drawings. And there you go. So that's exactly what I predicted they would do, and they did. So because conversions are the same, right? For anybody, you can do a problem that's already made, and chances are you're going to repeat the same thing. There are other ways to go about it, obviously, you know, but this is one. All right, so let me go to, is there another problem? This is what is known as dimensional analysis. Okay, this one's much simpler. Okay, United States says your European hairdresser wants to cut your hair 8 centimeters shorter. How many inches will she be cutting? Remember, we have that equality that says 1 inch is equal to 2.54 centimeters. So let me write that down for you. And that's in your chart that I told you. In these being conversions, you do not worry about sig figs with these. The sig figs come from this number. And remember, we need to identify where we're coming from. We're coming from centimeters, right? And we want to go to inches. So we start with what we know, which is 8.0 centimeters. Then we need to put this conversion factor in a way so that the centimeters cancel. So that means the centimeters have to go in the bottom, and centimeters and 2.54 go together. So 2.54 goes on the bottom, and then 1 inch goes on the top. And all you have to do is divide. So it's 8 divided by 2.54. And that gives me 3.15 inches. And since it is 2 sig figs, it's really 3.2. So okay, now let's see what they did. Okay, see, same thing. We want to go from centimeters to inches. 1 inch is equal to 2.54. They divided and they got 3.2. Same thing I did. Because the conversions don't lead you astray. They always show you the way. How do they show you the way? Because the conversions themselves have units, and your things that you want to convert also have units. Then you know where to place the numbers based on that unit. Remember, it was 1 inch is equal to 2.54 centimeters, right? And we had centimeters to begin with. So centimeters has to go on the bottom. That means the 2.54 goes on the bottom and the 1 inch goes on the top. And then you know that if they're on opposite sides of the little boxes, right? Like if one's on top, one's on the bottom, they're gonna divide. But if they're both on top, they're gonna multiply. And that's how that works. And I think that was, okay, here's another one. All right, once again, you notice we're going from centimeters to yards, right? So this one should be easy. Centimeters, we're gonna go all the way to yards. But we have inches in the middle somewhere in here, right? Okay, so we have 550 centimeters. And we know for every centimeter, for every inch, sorry, we have 2.54 centimeters. That's how we're gonna convert to inches first. And then how many feet in 1 yard? There, I mean feet, sorry, inches in one yard. I'm not sure, but there are 3. Okay, so we still gotta go somewhere in here. There's gotta be feet too, right? Because inches is easier to go to feet. So we know that there are 12 inches in 1 foot, right? And we know that there are 3 feet in 1 yard. See how we got there? We know all these things, right? Yep. All right. So what do? Well, we have all of the tops are 1s. You see that? So we need to say 550 divided by, and open a new parentheses. Remember that? Say 2.54 times whatever's on the bottom. So 12 times 3, right? And that's gonna close that parentheses and hit equal, and I get 6.0144873, blah, blah, blah. We have 2 sig figs here because remember that 0 doesn't count. So we have 2 sig figs. So that means that 6.0 would be our answer. Let's see if we got it right. All right, so to do that, okay. See, they might have gone a different path. We don't know yet. Well, apparently not. Okay, yeah, 1 foot is 12 inches and 1 yard is 3 feet. Yep, they went exact same path. So 6.0 yards. You see that? Exactly what I said it would be. All right. So let's clear all the drawings because we don't want them anymore. You see, it did work. So every time that you're converting something, you have to create a path to get to where you're coming from. And I'm gonna make a path for you right here. See, you knew you needed inches first, right? Then you knew you needed feet after that. Then you could go to yards. You see that? And see, all of the ones that are here are also on the top here. See? Your path is very clear. So all you have to do is find the conversions. And we know that one inch is equal to 2.54 centimeters. Centimeters has to go on the bottom because they want to cancel. Then we know we need to go to feet next because feet and yards are okay. And inches and feet are okay too. So that's like the communicating, the mediator between inches and yards. So we have inches. We know that there are 12 inches in a foot. So inches has to go on the bottom because inches has to cancel. So they have to be in opposite sides of the division sign, right? And then feet is next. And we know that there are 3 feet in 1 yard and we wanted to go to yard. So we leave yard alone, but feet cancel. Now, how do we know what to do? Well, the top is telling us that we need to multiply 550, and we're not having units anymore here, times 1 times 1 times 1. So we just leave it alone, right? and then we divide it by the product of the bottom. So we have 2.54 in the first one, and that multiplies times the second one, which is 12, and that multiplies by the third one, which is 3, and that gave us 6.0148, okay? And remember, sig figs, there's only 2 here, right, that count. So we need to limit this to here. And we know that this is not large enough to make that go to 1, so it's just 6.0. And we know the answer is yards because that's where we were going. And there you go. And that was the only thing left too. And that's how we do it. All right, so let's clear that one. And I think that's the last one that we have. Nope, there's one more. Okay, this one, once again, is the same thing. So we need to convert meters. Oops, I keep forgetting to do that, to not do that, sorry. Here we go. I need first to hit the draw. Okay, we need to convert meters to centimeters. Okay, for that we will need the ladder, you know, the one that I showed you, the first one that I showed you. Let me see if I can escape this one. Oh, I need my mouse. Come on, escape. It's not letting me escape. There we go. Okay, and we need this one. Remember, we're going from meters to centimeters, right? Okay, meters, here is that unit. Remember the unit we're calling meter. Oh, wait, let me, I need to do something with this and it's not, there we go. I need to enable editing or it won't let me write on it. Okay, let me clear all these drawings. Well, no, actually we're gonna leave them. All right, so we're going from meters, right? And remember the unit, like I said, the unit, which is the one with no prefix, right? Is equal, in this case, to meter, because that's what we're giving it, the value of meters. And we wanna go to centimeters, right? Remember, centi, right here. Okay, so since we're going 1, 2 down, remember down, downward is a positive. And we said that we're multiplying whatever it is times 10 to the 2, right? Because it is going down. And 10 to the 2 is actually equal to 100. So you can do either one. Up to you which one you want to use. Okay, since we're going from unit, so we're going from meters to centimeters. All right, so we got that down. Now let me go to the next one. Go back to this, okay? And I'll show you how that works. Okay. See, I left everything like it was. Okay, so we're going from meters to centimeters. And we're going from 1.3. Okay, so let me go 1.3 meters. And I usually like to write down, you know, the bottom as 1, because that way I don't have to divide. And we said that that would be 1 times 10 to the 2nd centimeters. Or if you want to just call it 100, we can do that. Let's call it 100. Okay, and that's centimeters. So meters cancel. See, that's how we know where to put it. Okay. So the one thing that we want to know is how many pieces of wire. So 1 centimeter is here. So since we have centimeters up here, 1.5 centimeters goes down below. And that is 1 piece, right? All right, so let me erase some of these things so we can just get rid of these, because we already know that and we already know this, okay? So what we need to do is the math. which would tell us that we're multiplying 1.3 times 100 and dividing it by 1.5. And then divided by 1.5, we get 86.7 pieces. Okay. Now the thing about this, okay, that's what it really is, 86.67. Okay, but they're asking us how many pieces of this size can we cut? So obviously the answer is 86. This number does not count because that's part of a piece, right? So we can only really cut 86 pieces from that. This is what is known as an exact number. You cannot have parts because then it wouldn't be a 1.5 centimeter piece, would it? Logic can tell you that. All right, so let's look again and see what they've done. They probably did exactly the same thing, except they probably put it, no, they did it just like I did. Okay, see? And the answer is 86 pieces. And that's why. Do you see why? This is known as dimensional analysis. It's the way to convert anything you want into something else. And we're going to do a little bit more on that, but I just wanted you to see how it's useful to have that. Like if you were doing a craft, for example, and it called for so many pieces of wire or so many pieces of ribbon or whatever of a certain size, and you knew how many yards you have, you know, you could convert that to how many pieces you would need, right? So that's exactly what this is, same thing. It really is applicable to real life situations, believe it or not. As a matter of fact, if you're traveling, let's say to Canada, you bring dollars, they have Canadian money over there. It's a little less than $1. So you want to buy something, but you don't know if you have enough, well, you can convert because, you know, I mean, you have 15 bucks, let's say it's worth 25 Canadian dollars. Canadian dollars, like I said, are a little bit less. So I don't remember what the actual, I can find out. Let's see. Hey, Google, what's the conversion between dollars and Canadian dollars? It's 1.30, okay? So we just did that, right? We just said we wanted to say it's $15. Okay, so let me do it right here on this thing so you'll see how easy this is. So we're gonna say 15 Canadian CDs, right? CDs for Canadian dollars. No, sorry, US dollars. Sorry, UD. We're gonna call it UD for US dollars. Okay, so we have 15 UDs, right? And for every UD, you have 1.3 CDs, right? Canadian dollars. So how many Canadian dollars do we have? Well, let's see. Can we actually buy something that's worth 25? I don't know. Let's see, 15 times 1.3. No, we don't have enough. We only have $19.05 of Canadian dollars. You see that? So no, you don't have enough money. You see? See how fast we could do that? So that's one of the things that I was telling you. This is useful for a lot of things. And this is one of them right here. Or like you're cooking and you want to know parts of a recipe, that works too. Okay. All right. So let me stop this sharing right here. Okay. Let me go to this next other screen. I need to go to it first. There we go. Okay. Now I'm going to share my screen. All right. First, I need to escape this. I keep forgetting I have to escape this thing first. Sometimes this thing is annoying. Come on, escape. There we go. Finally. All right. So we went back to here. All right, so where we were talking about was the metric system. And I told you guys to download these two charts, right? So you'll have them at all times. And if you're coming to class, I don't have a copy of it, but I can make copies if you bear with me for like a few minutes. I can go upstairs, make copies of these, and we'll do that. But the very first thing is this. We're going to learn how to do dimensional analysis properly. And this particular little sheet here, this will help you figure out dimensional analysis with weird stuff. You know, things that aren't necessarily the things that you're used to. That's why I say weird stuff, because it's more of a, okay. So right here. Okay, see how it says convert dogs into legs. All right, so if you have one dog, normally dogs have 4 legs, right? So in order to convert, see, you just treat this as an equality. So how do we do that? How do we convert that? Using our dimensional analysis, which is the best way to do it. That way you won't get it wrong. You would have to say, okay, so we know we have 5 dogs, and I'm just calling them D's for dogs, right? And it says here 1D, right? So 1D goes below because we need to cancel, right? It's equal to 4 legs, so 4 L's. So the answer is 20. And you knew that before I even got started. I know you did. But there you go. See how I did it? It just multiplies the top and it gives you 20. All right, let's convert days into hours. Okay, this one's a little more challenging, right? Because we don't know it right away. All right, so we have 15.2 days, and we're gonna call them D's, so I don't have to write all that because it's hard to write on this. Okay, you notice it says 1 day is 24 hours. So 1D goes below, right? Because we wanna cancel the D's. And then the 24.0 H goes there. All right, we have 3 sig figs, so our answer can have 3 sig figs. So we need to multiply 15 times 24.0, and that gives me 360. So the answer is 360 hours. You see that? HR actually, because that's what most people do. All right. See that? That wasn't so hard, was it? Because it makes sense. These are things you are familiar with. All right, let's do the next one. Okay, so this is 30 centimeters. Oops, let me get it. All right, 30 centimeters, and notice it's 30.0, which means you have 3 sig figs that you can use. All right, now look at where centimeters goes with. 2.54. So 2.54 centimeters has to go on the bottom. Why? Because centimeters has to cancel, right? And inches has to be what prevails, because that's where we're going. All right, so then you can see we're dividing, right? 30.0 divided by 2.54 gives me 11.81, so but we can only keep 3 sig figs, so 11.8. See that? So far, so good? You following me?
Yes, ma'am.
Okay, let me clear that. Go to the next one. Oops. I forget, in order for me to move this thing, I actually have to push the mouse and go to the next page. Okay, now clear all that. All right, so now we want to convert something that you've probably never heard of, but that's fine because you have your conversion right there. They say to convert 3.5 pounds into newtons, okay? So 3.5, that's a period there. Sometimes these periods don't want to come. In pounds, you know, it's LBs, right? And we're changing to, you notice where it says pounds, right? So 0.225 pounds goes on the bottom, and 1 Newton, and we're just gonna call it 1 capital N because that's the actual symbol for it, goes on top. So when we divide, because obviously this is a division, right? We get pounds away, right? they cancel. So we divide out 3.5 divided by 0.225, right? And that gives me 15.55555. But we only have 2 sig figs, so the answer is 16, right? 16 newtons, because it was 15.5555. So that 0.5 is large enough to make that 5 go to 6. Therefore, it's 16, not 15. All right. So far, so good?
Yes, ma'am.
Yes. Okay, good. Now let's go next one. I'm going to let you do a couple of these. Okay. I want you to set up the next one for me. Tell me what to do and I'll write it. Okay, did you guys get it? Okay, well, you didn't say anything, so I'm going to show you. Okay, 1.23, that's what we start with, right? Times 10 to the negative 3 kilometers.
Okay.
Okay, our next step would be to do this, right? So kilometers goes on the bottom because we want to cancel, right? And 0.621 miles goes on top. Okay, so when we multiply, we get, well, 0.764 times 10 to the negative 3, right? Because, well, you weren't here for that part maybe, but when you multiply something with an exponent, you multiply the m part first, the m being the number, not the exponents. And that gave me 0. So I'm gonna write it up here, 0.76383. That's what it gave me. But then you keep the exponents, right? Okay, that's incorrect scientific notation. So what I always do is if I increase it by 1, because the number before the decimal, right, which is the 7 in this case, see that's a 0 for here. has to be between 1 and 9, and 0 is not. So then you need to move it up 1. And since you're increasing, you need to decrease over here. Okay, so that gives me 7.6, and we only have 3 sig figs, so 6,4 times 10 to the negative 4. That's a weird 10, but that's a 10. All right. So see, that one was a little more complicated because it has sig figs, not sig figs, I'm sorry, it has scientific notation, which does the next one. See, in chemistry, we have very small numbers like these right here, molecules into moles. That is hard, that, you know, not hard, but it's, you have to apply the principles for scientific notation with that one. So we're gonna do that again. All right, so in this case, we have 1 point. All I wanted for you was to set it up, because if you don't know something, it's okay, as long as you can set it up. And we're gonna call these molecules, so M-O-L-E-C, right? Molecules. And we're converting it to moles. Okay, notice what goes with molecules. So you need to divide it by 6.022 times 10 to the 23rd molecules in 1 mole. Okay. All right, so we're dividing, see, because they're in opposite sides of the line. All right, so since they're in opposite sides, we need to divide 1.204. And if you have the type of calculator that I suggested, you need to do second EE 24 divided by 6.022 second EE 23. And I get 1.9999999, right? And we have 4 sig figs, so we can keep 4, and that is 1.999. And the next number is a 3, so that stays like it is, it's not 2. And that is times 10 to the nothing, right? Because it canceled out. So times 10 to the nothing, so that's the answer. All right. And that would be moles. Okay. That's how you do that one. And the answers are here, by the way, on the bottom. You're about to see them. But what I wanted you to see more than anything is that you can set it up. That's the main thing. It's not that you can have the answer. The answers are right there already anyway. And I disagree with this one with sig figs. This is incorrect. I do not agree with that. It really should be 1.9939, 1.999, because the next number was a 3, so that does not become 2. All right, anyway, this next one, we're going to forget these that are right here. You're gonna forget all of that. And because we wanna do what is known as a multi-step. And in order to do a multi-step, you have to put things correctly. So what does 16 meters per second mean? That means that for every 16 meters in 1 second, you travel that much, right? Okay, so now the next step, you notice it wants us to convert to miles per hour. So there's 2 ways of doing this. We can convert meters. In my case, I do have an actual direct conversion to miles, which we used earlier, remember? But first we gotta convert to kilometers. So we need to say 1 meter is equal to 10 to the negative 3 kilometers. Okay, the next thing to do now is to take the kilometers to miles. So 1 kilometer, in this case, we said it was 0.621 miles. Okay, we had the mile part, right? But they're 1 per hour. Well, this is per second, correct? So now we need to convert the second. So there are 60 seconds in 1 minute, right? And there are 60 minutes in 1 hour. You notice that we want the hour to be on the bottom because we started on the bottom. So seconds would cancel. See, seconds and seconds, minutes and minutes, and we ended up with miles per hour. Okay, so all you now have to do is multiply the top by the bottom and divide it by the bottom, which the bottom really doesn't have anything. So that's why I like to put it on the top, like I was telling you. I mean, when you're doing miles and kilometers and meters, you can choose to put 1,000 on the bottom, but then you have to do the 1,000 division on the bottom. So instead, I like to put it on the top and just multiply that with second EE -3, and then times 0.621 times 60 and another 60. And that gives me 36.11 miles per hour. So we had only 2 sig figs, therefore the answer is 36 miles. See? And that's actually right here. Hold on. Let me show you the answer here. It's already on here. See, 36 miles per hour with sig figs, which you want sig figs, by the way. All right, so clear all that and do the last one. Okay, can you guys do this one? Try it. See what you get. You notice the answer is right there already, right? I just want you to see if you can convert it. See if you can actually set it up correctly to get that answer. Mm-hmm.
Yeah.
You got it?
I mean,
did you set it up? That's the main thing, is to be able to set it up, right? And you can multiply, divide the rest of the time, but yeah, the setup is what tells you where to go. And you have every tool right here. They gave it to you on the side, on the right side. You have all the conversions that you're going to need. So basically, they made your life much easier than I would have. I wouldn't have given you those conversions. I would let you look for them. And we have them, you know, it's just in our chart. But you would have had to figure out the path. But we know we want to go from kilometers to inches, so we have to use all of them. So if you're ready, I'll show you. You guys ready? And this will be the last thing we do today. Yeah? Okay. So you always start with what they give you, right? That's the very first thing. We always start with what you know. And you know that you have 14.6 kilometers. So my next setup, where does kilometer have to go? On the bottom, right? Because 1 kilometer needs to cancel with kilometer. And then the top says that there are 0.621 miles. Okay. Now notice the next one tells me that 1 mile is 5,280 feet, right?
Mm-hmm.
But it's not feet that we want, so we have to keep going. Then we have 1 foot, right? Is equal to 12 inches. See? So now kilometers cancel, miles cancels, feet cancel, and you got inches. And that's what you wanted. So all you have to do now is multiply. 14.6 times 0.621 times 5,280 times 12. And you get a huge number, and I expect a huge number. And in order to do only 3 sig figs, you have to either cut it down or give it in scientific notation, which would probably be the easiest way. But my number that I have is 5,000, no, not 5,000, 5,744. Let me see how many. 574,459.776. That's what I got. Okay. So that's a huge number. And there's way too many sig figs. We can only have 3, right? So 3 would be there. So according to the rules of scientific notation, you just got to move it 1, 2, 3, 4, 5, because that number has to be, that first number right there has to be between 1 and 9, right? And 5 is, right? And we moved it how many spaces? 1, 2, 3, 4, 5, right? And this number is larger than 1. So the answer is going to be 5.74, because that's our 3 sig figs right there, right? And this number is not large enough to make that go to 5 times 10 to the 5th inches. And look at that. That's exactly what's down here. See that?
Yeah.
Mm-hmm. They did that one right. They got a couple of them that do not work with scientific, with their sig figs that they're calling, like this one, for example. This one, yeah, that one I did right. And this one, I mean, I've erased a bunch of them, but that's, you know, that like the 2 moles, that was definitely not correct because it was 1.99939 in the 3. And that 3 did not make it go to 10. So therefore it didn't all turn to 2. That one's incorrect with their sig figs. Well, I just found this and I liked it because it's good, but I can't, since it is a PDF, I can't change any of this, but I can tell you that the sig figs are wrong on those. Okay, so that's basically it. So that is how you would do conversions from now on. We're using what is called as the dimensional analysis or factor label. Okay, so if you want to try it out on your own, you know, you've got all the answers right there. And if you get the right answer, you know you did it right. And that's why that's there. All right, ladies, we are going to stop here. Oh, lady.
Yes, ma'am.
All right, and are you coming to the class physical tomorrow? You know, we're in person.
Yes, ma'am.
Okay, I will see you there and meet you.
I know the calculator you're telling us.
Hold on, let me close this recording.